we should probably just use the ones that we were given. So we were given at 4 p.m. he's 260 miles from home. So that's right here on our line. And that will be at 4 p.m. He's 260 miles from home. Okay. And then our second point is right here. And we know that at 7 p.m. he is 455 miles from home. So when we do rise over run, y over x, okay, this again is just our x1, y1, x2, y2, okay. So we take y2 minus y1, that would be 455 minus 260, okay, and that should get us 195. You plug that into a calculator, or just use your phone calculator. Okay, and then we put that over x2 minus x1, so 7 minus 4 gets us 3. When you divide 195 by 3, you get 65. Okay. It also wants us to interpret what the slope of the line means. So we found that the slope is 65. Okay, so what? We need to look back at our problem and determine what this problem's talking about and what it's really asking for. Okay, when we look back, we see how far he's gone in a certain amount of time. Miles and hours, right? He's traveling miles, and we're looking at it from 4 p.m. to 7 p.m. So this is talking about 65 miles per hour is how fast he's driving. Okay, so that's our slope for this problem. What do we know about two lines on a coordinate plane with the exact same slope? Okay, we should all recognize these two forms of lines right now, and the y equals mx plus b. Okay, here's our slope next to our x, and our y-intercepts right out here. Okay, so if we graphed these, we'd start our first line at -3, okay, and we'd go up 2 and over 1, up 2 and over 1. Okay, so sorry, my line is wonky, but that's roughly what it'll look like. Okay, down a little bit further. And then our other line will cross at +4, okay, up 2 over 1, up 2 over 1. If we go backwards, we go down 2 and left 1, okay, which means our other line will look something like that, okay. Seeing that if they have the exact same slope, they'll never run into each other, meaning that they are parallel lines, okay. So our next slide talks about a theorem dealing with parallel lines. Here we have our parallel lines theorem. I guess in the book it's theorem 3-5-1. And it basically just says in a coordinate plane, two non-vertical lines are parallel if and only if, remember, we learned this, IFF is if and only if they have the same slope. So that means we can read it forwards and backwards. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope, and if they have the same slope, or they have the same slope if and only if two non-vertical lines are parallel. Okay. We had to add this second bullet that says any two vertical lines are parallel. Okay. Because slopes of vertical lines are always undefined. All right. Okay. So when I made these slides, I made them in for a smartboard, but now I'm just taking screenshots of the slides, so my filled-in shapes here are just blocking the words that I need. So I'll just write them off to the side. But what do we know about slopes of lines on a coordinate plane that are perpendicular? Remember, perpendicular are that they meet at 90 degrees. Slopes that are, or lines that are perpendicular or have slopes that are perpendicular have slopes that are opposite reciprocals. So opposite, okay, reciprocal. Oh god, this pen is really difficult to use. That says opposite reciprocal. Let's see if I can fix that, because that is just rough to look at. Okay. Reciprocal. No, I don't know if I spelled it right. Nope. Reciprocal. Okay? So opposite reciprocals mean when I take this slope right here, 2 is my slope. My original slope is 2 over 1. Okay, opposite means my sign changes, so now I need a negative slope. Okay, so when I rewrite my new line, I need a negative slope. Okay, and I need it to be the reciprocal. Okay, reciprocal just means I flip these two numbers. So now I have a negative out front and a 1 on top and a 2 on the bottom. Okay, so that's all opposite reciprocal means. Okay, so that's our slope. And then our y-intercept isn't as important here. So when we're looking at graphing our first line, we start at 1. Okay, we start at 1 on our y-axis. Okay, and then we're going up 2 and over 1, up 2 and over 1. If we want to go the other way, we can go down 2 and backwards 1, down 2 and backwards 1. Okay, so that is our first line. We need a line that is perpendicular to that. Okay, so we have our opposite reciprocal slope. All right, so wherever we want to start on our y-axis can be our y-intercept. So let's just say 3. Okay, it's a nice middle of the line place to start. So we can go to 3 there. Oh, that's kind of there. And then down 1 and over 2. Down 1 and over 2. Down 1 and over 2. If we want to go backwards, we go up 1 and back 2. Up 1 and back 2. So these lines are guaranteed to cross at exactly 90 degrees because of their slopes. So we made them opposite reciprocals, meaning they have to be perpendicular lines. So here is our perpendicular lines theorem. In the book it is 3-5-2. So in a coordinate plane, two non-vertical lines are perpendicular if and only if their slopes multiply to -1. Multiplying to -1 is still just the same as opposite reciprocals. Okay, so it still means the same thing. And also that vertical and horizontal lines are perpendicular. Okay, so if my slope is undefined and my slope is 0, those lines are perpendicular as well. The ratios a over b and negative b over a are called opposite reciprocals. So here's another example of what opposite reciprocal means. Opposite is just that my sign changes from positive to negative or from negative to positive, and then reciprocal is just flipping the fraction. And we've made it to our last slide here. So this says, is line AB parallel, perpendicular, or neither to line GH? So here you should go ahead and pause this video and work this out yourself so that you can understand how to do this. If you start getting stuck and or need to check your answer, that's when you can continue playing the video, but I would really like you guys to start and attempt this on your own first. So pause now. Hopefully now. If you come back to this, we're looking at line AB. So again, not trying to be tricky. X1 and Y1 and X2 and Y2 here. Okay, so when we put it into our slope formula, Y2 minus Y1, we have -10 minus 2 is -12. Okay, over X2 minus X1, so 2 minus 6 gives me -4. Alright, so my slope here, -12 divided by -4 gives me +3. So my slope, we can write m of AB, okay, is 3. Okay, and then moving to line GH, again, G is our X1, Y1, oops, it's my H is our X2, Y2. Okay, so when we put it in our formula, Y2 is -3 minus Y1, -3 minus -1, -3 plus 1 is -2. Okay, and then our X2 minus X1 is -2 minus 4. Okay, leaves us with -6. All right. So that gives us a positive 1/3 because my negatives cancel out, right? And so my slope of GH, okay, is 1/3. So looking at our two slopes that we found, right, 3 and 1/3, well, they are not parallel because 3 is not the same as 1/3, and they're also not perpendicular. They are reciprocals of each other, but they're not opposite reciprocals of each other, so these lines are neither. Okay. Okay, so you have made it through the notes for today. You can go ahead and start on your homework. It is on your calendar, okay? If you need to grab another one of those or a reminder of what that homework is, you can go to the absent bin up at the front of class, and in the geometry bin up there, it'll have all those purple calendars and packages. Sorry, again, ESPN's just going off over here. So go ahead and get started on your homework. If there are still people working on the quiz and you are done with notes as well, you can use your phone to listen to music, but that is absolutely it. If the substitute walks around and sees that you are doing other things on your phone, she will report it to me and you will get a 0 on your quiz, and we will have a meeting together because, again, I'm going to assume the worst about you and assume that that means that you're cheating. Okay, so please use your phone wisely, put it away if you don't need it, and just start quietly working on your homework right now.